for other obvious physiological reasons, there are natural and necessary violations in the intact barrier that the skin provides. We have mouth, nose, penis, anus, vagina. All openings to meet necessary physiological needs. Yes, no? And you know, mouth, nose, penis, anus, vagina, those are venues or avenues and opportunities, and most typically, the source of disease, the site of entry of many foreign pathogens. But we'll do those in just a moment. For now, let me suggest to you that the first line of defense, our skin, what's the pH of your skin as you get out of the bathtub? 4.2. 4.4, 4.5, 4.2. What does the book say, Mr. Rowe? 4.5. 4.5? It's something like that. Yeah, it's pretty acidic. Yeah? However, in the course of the day, ladies and gents, you know we're constantly perspiring. Doesn't have to be July. Even today, it's 9 degrees, whatever the hell it is in Newark. Your pores are open, and you are eliciting perspiration. Not like you will on July 4th when you're sweating like a dog, but there is fluid leaving your body, and whether you know it or not, your perspiration contains, not with the same concentration, but contains many of the same substances that your urine contains. So some of your excreta, some of your discarded matter is in your perspiration. It's not just cooling you down. It's also helping you eliminate. In the course of the day, your sebaceous glands, the oil glands in the skin, that are designed to keep your skin soft and supple, yes, not dry out like it does when they stop working. The sebum, that keeps your skin nice and fresh and lubricated and supple, it's a protein-based compound. So, the stuff coming out of your pores, the stuff coming out of your sebaceous glands, present a nutrient source for many of these little buggers that are in the atmosphere, the bacteria that fill the air. And they alight, they land on the exposed part of your body, and they start to feed off your secretions. They nourish themselves, and as they feed, they multiply. And as they multiply, they feed some more. And their bodily secretions raise the pH of your skin from 4.5 to something higher. And unless they're washed off and you start out again at 4.5 in a reasonable amount of time, the pH of the skin may continue to rise to a level which is high enough to become hospitable to these bacteria, and you get eczema or skin diseases. So the kid's got to wash behind his ears, you got to make sure he washes his hair, and so on and so forth, yes? So the normal pH of the skin provides a barrier, a defense against organismic growth. You remember the skin. Remember the skin is a keratinized, stratified squamous. What's the keratin do? What's keratin there for? It's instead of a turtle shell, it waterproofs you. When we came out of the water on land and we were warm-blooded, we were worried about where our body fluid was going to come from. We didn't know where our next glass of water came from, so we had to conserve body fluid. So we developed keratin to prevent evaporation. Ladies, in the emergency room, when you do your nursing, gentlemen as well, burn patients, their skin is lifted off, you're worried about disease, you're also worried about desiccation, drying out. So your skin is keratinized and waterproof. It's also toxic. The keratin that's on the outer layer of those cortical cells, corneal cells, C-O-R-N-E-A-L, your stratum corneum, remember? The keratin is toxic to many bacteria. You know of anything else that's toxic that's secreted onto a surface?
Earwax,
Earwax,
teardrops.
teardrops, lacrimal solution, yes, no? And we saw it earlier today. One cell, 2 cells, and then a ball of cells, and then a hollow ball of cells, and then the hollow ball of cells begins begins to invaginate. The invagination continues until ultimately this surface and that surface connect. Did we push the tennis ball through in this class?
No.
You take a hollow tennis ball, put your thumbs on it, and push till one layer touches the other layer on the inside. You push it. And eventually, it breaks through, and then you got a mouth and an anus. Yes, no?
Mm-hmm.
Well, this is the body wall. This is the body cavity. And that's your gut. So as the ball invaginates and elongates, and then snips off and opens, you got a tube within a tube, yes?
Mm-hmm.
For your intellectual edification. In this process, the first opening is your anus, the second opening is your mouth. See, we don't form our mouth first, we're proctodile. And that seems appropriate in some cases. Anyway, so something that enters the mouth, if it doesn't move out of the gut into the bloodstream, it's going to leave the anus, is it not? Anything that came in through your mouth and left through your anus was not in your body cavities. It really wasn't inside your body cavities. If the activity that goes on in this building is the classroom, just because you walk through the front door, if you keep walking up and down the hallways and never step into a classroom, nothing's done here. You follow? So traveling through the gut means the gut, from mouth to anus, really isn't inside your body, it's just passing through. So, anything entering the mouth is entering the mouth so that hopefully it can be reabsorbed. If not, it's never really been in your body. So it's still part of the surface or barrier part of your body, keeping things out of your bloodstream. What do you and I have from mouth to anus that'll help us in a membranous sense or a barrier sense to protect us? Just like tears, just like earwax, saliva in your mouth possesses very active carbohydrases, enzymes that digest starch. Most organisms have a starchy glycocalyx, an overcoat, a mantle around their cell membrane. Start to eat away at it so you can destroy the bacteria. Saliva provides a protective measure. If it makes it through the mouth, it gets into your stomach. Your stomach produces a very highly concentrated acid. And if the acid don't get you, then the enzymes will. If you went to the respiratory tract, you got a number of goblet cells in that pseudo-stratified, ciliated, columnar, epithelial lining of your respiratory tract. Yes, no?
Mm-hmm.
What I'm saying to you is the following. The body defends or protects itself at 3 levels. The first, the most obvious, the most generalized, is known as a surface, it's a non-specific, surface barrier or membrane defense, provided to you by the skin and the lining of your respiratory and digestive tracts, yes? If an organism or antigen or allergen, something you're allergic to that you react to, manages to break through the skin, survive the saliva, the tears, the mucus, the enzymes, or the acid, or gets in some other way, sexual activity, the friction associated with that causes micro tears in the capillaries on the penis and in the lining of the vagina. Material can be exchanged there. HIV virus, sexually transmitted diseases, yes, no? Blah, blah, blah. I'll leave it alone. In the event that the first line of defense with all its, well, with its several various devices is exceeded, We then confront the body's second line of defense, and I won't do too much of it. I'll introduce it to you here. Don't write. What else can you think of? We've talked about it just today and last Tuesday.
Mucus.
Done. In the respiratory tract. The mucous membrane of the respiratory, digestive,
Phlegm.
respiratory, and reproductive tract. Suppose you get past that membrane, then don't you have phagocytes? So there's the second line of devices is not a membrane, barrier, or surface. It's something called a cellular, and any chemical associated with certain cells that the body produces, again, in a non-specific effort. Neutrophils, phagocytosis, yeah? Can you think of any other phagocytes in the body other than monocytes and macrophages?
Natural killers.
NK cells?
Histamines?
Pardon?
Histamines?
Cells, phagocytic cells. How about microglia in the central nervous system? Did you talk about those? Wandering amoeboid neuroglial cells along neuroglial cells. Look it up. Micro, M-I-C-R-O-G-L-I-A. Google it. Look it up in your glossary in your textbook. It's in chapter 4. No, it's in chapter 8 or 9, whatever that nervous system one is. 13 or 14, 12, something like that. Anybody hear of Kupfer cells? K-U-P-F-F-E-R.
Yeah,
Where'd you hear about them?
my teacher last year said.
Where are they?
I don't remember.
They're in your liver.
There we go.
How about astrocytes? Blood-brain barrier, also chapter whatever microglia. It's another kind of neuroglial cell. The body has a variety of phagocytic cells in different locations throughout the body, which protect localized areas, yeah? There's a variety of different kinds of phagocytes. We'll talk about them and re-identify, I'll identify them for you again on Tuesday next. Beyond that, you have cellular responses, histaminic response, the complement, Ms. Carter, fever, and a few other things which we'll hear about on Tuesday next, okay? I've got 2 minutes left of your life. It's mine. Listen to me. Please have read chapter 17 in its entirety by next